This is R.D. Sharma solution, class 12, chapter 11, differentiation. Exercise is 11.5. We have x plus 1 by x to the power x and plus x to the power 1 plus 1 by x. So the first term, if it is different, we can do it differently or separately. We can call it as u. The other term we can call it as v, and all of it we can call it as y equals u plus v. So dy by dx will be du by dx plus dv by dx. So separately we'll do these two and finally we'll add them wherever it is required. So whenever we have a power, we generally go for the log. So u is x plus 1 by x to the power x. This is u. We'll take log on both the sides. Log u is equal to x log x plus 1 by x. Now let us differentiate it. When we differentiate it, there are two terms here on the left, on the right and left we have 1 by u du by dx. So x will take outside. I am applying the product rule. So log x plus 1 by x is 1 by x plus 1 by x. Then x plus 1 by x is 1 and 1 by x is minus 1 by x square. This we have already done earlier. So 1 minus 1 by x square plus log x plus 1 by x will be here and d by dx of x will be 1. Finally, this is the result. And we can now simplify them. So we take the denominator first, which is x plus 1 by x. So I am taking denominator. X plus 1 by x is x square plus 1 by x. And this goes up because this is in the denominator. So x square plus 1 by x goes up. It is going to be x square in the numerator and x square plus 1 in the denominator. And 1 minus 1 by x square will be what? X square minus 1 by x square. So x square minus 1 by x square. So what is the benefit? X square get cancelled. So the final will be u will be posted on the right. So du by dx will be equal to x plus 1 by x to the power x. This remain like that, the u. And what did we get inside? We got x square minus 1 divided by x square plus 1. This one and plus log x plus 1 by x. Now this is du by dx. The second part is to find out dv by dx. Alright? This term is final. You just have to keep it like that. There is no change. But when it comes to dv by dx, that is the differentiation of the second term. Let us do that and just add this to the first term, the result of the first term. So we have lack of space, so I am just clearing it. Now du by dx we have already found out. Now we are going to dv by dx. V is equal to x plus 1 power 1 plus 1 by x. So what it will be, this log v will be equal to 1 plus 1 by x will come in front and then log of x. Now let us differentiate this. So 1 plus 1 by x and this is 1 plus 1 by x. Log x is 1 by x. Then log x 1 plus 1 by x is 1 will be 0 and this will be negative 1 by x square. So this is going to be x plus 1 by x and you always have a x also. Now let us multiply inside. That is the better option. 1 by x into 1 and 1 by x into x square. That is 1 by x square and then minus log x by x square. So if you take the denominator, you can take the LCM. What do you get? You will get here x, then plus 1 and minus log x. So x plus 1 minus log x divided by x square. That is the final result. And one more thing we have to do, log v. So log v is 1 by v dv by dx. So dv by dx is computed by multiplying this with v. So final will be x plus 1, that is x to the power 1 plus 1 by, that is v. And this is x plus 1 minus log x divided by x square. And this is dv by dx. And dv by dx already found out. We just have to add them. That is the final answer. Okay. These two has to be added. Differentiate e raise sin x and tan x raise x. And there are two things. One way you can go about is by taking separately, log and doing them separately and then adding it collectively in the fag end. But there is another way also, because we know e to the power log is 1. So e to the power log can always be taken, and this e sin x or tan x to the power x, whichever is better to solve with using that, is a better idea. So we have e to the power log and base is e. So this tan x to the power x can always be written because e to the power log base e is 1. I've already discussed it while we started this discussion, when we were discussing about theory, etc. So e to the power sin x, then cos x. I'm doing the e to the power sin x, cos x. So e to the power sin x and sin x is cos x. Now e to the power log tan x to the power x will come in front. So we have to differentiate e to the power x log tan x. So we have to differentiate this. So e to the power x log tan x and x log tan x, because e to the power anything will be e to the power that thing only. And x tan x is x tan x, 1 by tan x, and tan x is x square x. Then we have log tan x and d by dx of x is 1. So x log tan x differentiation by product rule is this result. Now the result is e to the power sin x cos x. This is the result for e to the power sin x. And for tan x to the power x, the result will be what? This will remain like that. This will come like that. But see, tan x to the power x was written by us as e to the power log tan x to the power x. That we did. So that can easily be transferred or transformed into tan x to the power x, because that was the actual thing. We started with that thing only. So we have 1 by cos square x, x into sec square x by tan x. I am telling you 1 by cos square x by sin by cos. So this goes up and this cancel, and finally you have sec x cos x. So x is already there. You get sec x cos x, cosec x, and then log tan x plus log tan x. And as I told you, e to the power x log tan x, the whole differentiation is this, but still we have this e to the power x log tan x always there. But since we have ourselves converted tan x to the power x as e to the power x tan x, so you can always write it as tan x to the power x, because it is essentially like that only, because we did that, right? So that is how you can do it, and you can do it separately also. As I told you, you can take the 1 by 1, okay, that is u and v and du by dx and dv by dx, like that. Okay, so this is the tan x to the power x, and then we can just add them. So finally this is the result. Okay, and this content is tan x to the power x, which I have started earlier. Next is cos x to the power x, sin x to the power 1 by x. Again, you can take them u and v, du by dx, dv by dx, add them, that is the final result. But in order to do this, we always have that one thing, that is e to the power log can be cancelled. E to the power log e. So that is the one thing which always cancels itself, e to the power log. So when we take e to the power log, cos x to the power x can be written. Now x come in front, so we have e to the power x log base e cos x. Alright, so this cos x to the power x is, you can always write it as e to the power x log cos x, the base is e. Now we have sin x to the power 1 by x. U and v you can take, or you can use that the power of e to the power log. That is the utility of e to the power log. So e to the power log sin x into 1 to the power of 1 by x also we can write. So what I am trying to suggest here is e to the power log always you can write. Now this is 1 only. So after that you can write sin x to the power 1 by x. So e to the power 1 by x comes in front, log sin x it will be. So we have two terms, e to the power x log cos x and e to the power 1 by x log sin x. So what is the utility? See, u and v separately, du by dx, dv by dx, all this, that is a longer way to achieve the answer. Here you will see how easy it will be. because d by dx of this term, e to the power of anything will be e to the power that thing only. And this e to the power log cos x is nothing but cos x to the power x. Alright. Then the differentiation of x log cos x. X remains like that, and then log of cos x is 1 by cos x and cos x is minus sin x. Plus, now log cos x will take outside, differentiation of x will be 1. Alright. So this term we can directly write, because we actually started with cos x to the power x. So this is going to be cos x to the power x. Just replace it by cos x to the power x. This is going to be sin by cos is tan, and it is negative. So it will be negative tan x. So I am writing it out afterwards. Minus tan x x minus x tan x it is. What is log cos x? Log cos x is log cos x only. So cos x to the power x, log cos x minus x tan x. This from here to here, we have already done cos x to the power x. Now sin x to the power 1 by x, that is e to the power 1 by x log sin x. We'll do it now. So I'm just changing the color just to let you know that we are doing the second term, differentiation. Okay, so e to the power 1 by x log sin x, the differentiation of this will be this only. Now 1 by x log sin x. So 1 by x I'm taking outside. Log sin x is 1 by sin x. Sin x will be cos x. And then we have, I'm not writing plus because I know 1 by x differentiation is negative 1 by x square. So log sin x will be written like that, and 1 by x differentiation will be negative 1 by x square. So I'm writing negative here. So log sin x, and this is 1 by x square. You can always write like that, x square. So this is the final one. Just one change is there. Cos x by sin x, you can write it as cot x. So finally it will be, this has come from where? Sin x to the power 1 by x. So you have sin x to the power 1 by x, you can write it here. And inside that, we have a 1 by x cos x by sin x. You can always write it as cot x. So cot x by x it is, minus log sin x, and then we have divided by x square. This is the second term. So you have to add this one and this one. When you add them, that will be the final result. Alright. Now x to the power x square minus 3 plus x minus 3 to the power x square. So first term you can take it as u, second term you can take it as v. This is u, this is v. And then we write y as u plus v. Du by dx will do, dv by dx will do, whatever the result, we are going to add them up. So let us start with the first term. U is x to the power x square minus 3, and log u is equal to x square minus 3 log x. 1 by u du by dx is equal to, now differentiation using the product rule, x square minus 3 log x is 1 by x, then plus log, minus I am writing, just, no plus, let it be plus. Then log x will take outside, and then x square minus 3 will be 2x. Differentiation will be only 2x. And then final result will be, you have to take on the right hand side in the numerator. So this u will be x to the power x square minus 3. So x to the power x square minus 3 will come as it is. X square minus 3 by x you can write, plus log x and 2x. So 2x you can write first and then log x. So 2x log x. So this is your first result. So du by dx is this one. Then I am going to tell you, or I am telling you dv by dx, and that dv by dx has to be added to this term. Alright? You have to add to this term. So let us take this. We have v is equal to x minus 3 to the power x square. So dv by dx, first we will have to take a log v. So x square will come in front, x square log x minus 3 it will be. Here we will have 1 by v dv by dx, and d by dx of this right hand term, x square outside, log 1 x minus 3 will be 1 by x minus 3, and differentiation of x minus 3 is going to be 1, because minus 3 will be 0. So it will be 1 only. I am not writing it. Now log x minus 3, differentiation of x square is 2x. So you have x square divided by x minus 3, v also you have to take on the right hand side. So x minus 3 to the power x square, this is x square by x minus 3, and 2x will come in front, and then log x minus 3. So this term has to be added. They see these two are the results. So these two results have to be added, and this term plus this term, the blue one with the green one, and that has to be added, and that is going to be your final result. Y is equal to e to the power x plus 10 to the power x and x to the power x, and we have to find out the dy by dx. Now you see, e to the power x differentiation is direct e to the power x. You don't have to do anything. 10 to the power x, that is a to the power x, is a to the power x log a. So 10 to the power x log 10. X to the power x is the only thing, and we know e to the power log is always 1. So you can always have e to the power log any term, x to the power x in this case. So when you have, you can always take this as w, and w is x to the power x, log w will be equal to x log x, 1 by w, dw by dx is equal to x, let us differentiate it. So x will x, log x is 1 by x plus log x, and d by dx of x is 1. So 1 plus log x it will be. Okay, and then w is already there, so you have to multiply it with w, and w is x to the power x. So the final result will be x to the power x 1 plus log x. So this is one way of doing it. It's a faster way to do it, and the other way is by using e to the power x log x to the power x. That will become e to the power x log x. Now you can apply the differentiation here. E to the power thing will be e to the power thing that. Now what is this one? I told you log e is 1. If the base is e, log e is 1 because e to the power 1 is e only. E to the power 1 is e only. So this log base e is 1. So in place of 1, you can always write log e. That is the only tricky part here. In place of 1, you can write it as log e because log e base e is 1. And plus log base e x. Now log a plus log b is what? Log a into b. So you can write it as log e into x. And x to the power x is already there. So this whole term, you can write it as like this. So x to the power x log ex, that is how it has come. The rest all e to the power x plus 10 to the power x log 10 will remain like that. And second way of doing this x to the power x is e to the power log x to the power x. It will become e to the power x log x. When you differentiate it, the result will come same. The tricky part is only one, which is log e, which we have written, and then we applied the log property. This question will take in the next discussion. Till then, thank you so much and take care of yourself.